NHT exam 1 question 2 walkthrough. So I will highlight the key point on how to do these questions. So let's go through this together. So we have this question here. Consider the simultaneous linear equations. So we have two equations that are written in terms of a, where a is a real number. So for a, it says find the value of a for which there are infinitely many solutions. For b, the value of a for which there is a unique solution, and the value of a such that the lines meet at the right angle. Because each of these two equations here, they are linear equations, so we can all turn them into the form of y equal to mx plus c. And in here we need to understand one key point, that is infinitely many solutions, right? What does it mean graphically? It means that for two lines to have infinitely many solutions, it means that they will have infinitely many intersections. Does it make sense? Infinitely many solutions between the two linear equations mean in this case that they will have infinitely many solutions. So let us consider the graph here. So I will draw a straight line, and this straight line I can label it as y. Label it as y1 equal to m1x plus c1. C1. Okay, I'll draw it again. Let me type it again. So y equal to m1x plus c1. Okay, now and then from here I will also draw a second straight line, and because this is a straight line, therefore it will also have the equation of y equal to m2 of x plus c2. Right, now, so what are the conditions so that these two lines, they will have infinitely many solutions? So let me turn this line in, let's say in pink color. Now, what are the conditions for these two lines to have infinitely many solutions? Okay, it would be when they are overlapping each other, right? Can you see? So what happens when they are overlapping each other? It is when they will have the same gradient and also same y-intercept. Once again, infinitely many solutions, it means that the two lines will have the same gradient and also at the same time the same y-intercept. Is it understandable? So this is the key point. And I will turn it into text as well. Right. So, okay. So mathematically, it means that M1 must be the same as M2, and at the same time, C1 must be the same as C2. I hope it is understandable. Yep. C1 equal to C2. This is the key. Now, how can we apply it in this question? Because right now, both of the equation, they are not written in the form of y equal to mx plus c, right? So our very first step for A, we should turn each of these two equation, I will call this one equation number 1 and then equation number 2. Right, let's turn both of these equations into the form of y equal to mx plus c. So let us do it for the first equation. So here, now, so for this first equation here, what I can do is I can to turn it into the form of y equal to mx plus c. What I can do first is I can take away ax from both sides. So okay, I just copy this question, take away ax from both sides. So 2 minus a times y will be 3 minus ax, right? And then after that, I can divide both sides by 2 minus a. So therefore, I will have y equal to 3 minus ax divided by 2 minus a. So this form, right, this is almost there. So how can we turn it into the y equal to mx plus c form? We can split this fraction. Yeah, we can split it into, the first fraction is 3 over 2 minus a, and then minus the fraction of ax. Okay, ax times 2 minus a. So we turn this fraction into this form. Now it's very close. So okay, in this case, what is the gradient and also the y-intercept of this equation? So let's turn this into the standard of y equal to mx plus c by how to do that? By rearranging the terms. So here, what I can do here is I put the x here, and then I will plus the second term here. So in this case, it's clear to us that this part here, let me make it to have yellow color. This term, it will be our gradient m1. Does it make sense? So under brace, so this will be the gradient, right? And this one will be the x-intercept c. Does it make sense? So in the same way, we can also turn the second equation. Into that form. So for the second equation, in the same way, we can also turn this one into the form of y equal to m of m2 of x plus c2. I hope it's understandable. And then, so for these two to infinitely intersect each other, it means that they overlap, right? They will have again the same gradient and the same intersection. So by making this, by making m1 equal to m2 and also c1 equal to c2, we will have an equation to solve for the value of a. Is it understandable? Now, so notice one thing. So I have worked it through before. So when you solve for m1 equal to m2, this will be the quadratic that you will have. And so from here, you can easily deduce that a will be -2 or a will be 1, right? And now, so for the second quadratic, when you solve for c1 equal to c2, then you can easily find that a is -2 or a will be 1 over 2. Does it make sense? Now, because we want that we want same gradient, right? And also same y-intercept. This is what we want. So we want the value of a that will make m1 equal to m2 and also c1 equal to c2. So what is the value that would allow that to happen simultaneously? It is when, now when a equal to 1, right? Yes, it will make m1 equal to m2, but a equal to 1 will not make c1 equal to c2. Likewise, when a equal to a half, right, then it can make c1 equal to c2, but it cannot make m1 equal to m2, right? So only the value of m that satisfy both of these equations here, then you will select that. The value of m that satisfy both of these equations will be a equal to -1. Does it make sense? So the answer for a is m equal to -1. Then for b, what does b say? Find the value of a for which there is a unique solution. So what does unique solution means graphically? Unique solution means that they will intersect once only. Is it understandable? They will intersect once only. That is when unique solution happen. So when we look at the graph here, I just copy this graph. Okay, so we focus on part B, that is unique solution. So borrowing from the graph again, what does unique solution mean? Unique solution means that they will intersect each other once, right? So what are the conditions of M1, C1, M2, C2 so that they will intersect one? If you pay attention, if we look at closely, actually the value of C1 and C2 doesn't matter, right? This is C2, this is the value of C2, this is the value of C1. Then the value of C1 and C2 does not matter, actually. But what really matters is M1 and M2. So for the two lines to have unique solution, then what is required is that the gradient of the first line different from the gradient of the second line. That is M1 is not the same as M2. Is it understandable? So when M1 is not the same as M2, then the two will definitely intersect each other. And now you may ask, what if C1 equal to C2? C1 equal to C2, when they have different gradient, just mean that they will intersect at their y-intercept. Does it make sense? So when they intersect at their y-intercept, in this case here, yes, the gradient is different, therefore they will intersect, and they will intersect at the same y-intercept. Their intersection will be their y-intercept. Is it understandable? Now let's go through how to solve for this equation. Now notice, right? This is a not equal inequality. Then how can we solve for it? Then if you remember from part 1, M1 equal to M2, this is what we have from previous part. So when M1 equal to M2, we will have this simultaneous equation. Therefore, when M1 is not the same as M2. Okay, now let's solve the equality first. When A plus 2 times A minus 1 give us 0, so it means that A will be -2, right? Or A will be 1. Does it make sense? Now, but what if for the case of inequality? Then what can we deduce? So once again, so for this quadratic to be 0, then A equal to -2 or A is 1. Then what if I want this quadratic to not be 0? Then how can I select value of A to make this quadratic to not be 0? Then as long as it is not A, as long as it's not -2 and not 1, then the quadratic here will not be 0. So you will select A that is not -2 and A that is not 1. Now the keyword here is actually the and, right? Why? Because they must, the number that you select must not be -2 and also must not be 1, right? is understandable. So you need to change this or to n, because the number that you select, as long as it equal to either of these, then it will make this quadratic zero or the gradient to be the same as each other. I hope it is clear. So we need to negate this or into an n to figure out the solution of not inequality. Now, here it is also important to mention that when for a time b to be 0, this is the no factor law. It means that a will be 0 or b will be 0, right? However, if you do the not inequality for a time b to not be 0, then the thing here is a must not be 0, and at the same time b also must not be 0. I hope it's understandable, right? 0. So these are the key. All right, now let us go to part C. Now find the value of a such that the lines meet at right angle. So the key point for this question is, when is it that the two lines will intersect at right angle? Do you know when the two lines will intersect at right angle? It is when the product of their gradient, the m1 times m2 will give us -1. So you only need to figure out what is the gradient of the first line and the gradient of the second line multiplied together, it give you -1. So when you solve for this, you can figure out the value of a so that the two lines will meet at right angle. So this is the key we need to remember. So once again, so for the two lines to meet at right angle, then the products of the gradient need to be -1. Also, for the two lines to intersect, right, infinitely many times or have infinitely many solution, the solution, the criteria, the condition will be the gradient is the same and also the y-intercept is the same. So it will be m1 will be equal to m2 and c1 equal to c2, right? And for the two lines to have unique solution, then what is required is that their gradient are the same, as long as the gradient are not the same. m1 is not the same as m2. In this case, c value c1, the first x, the y-intercept of them, actually they do not matter. And also lastly, when they intersect at right angle, then the product of the two gradient will be -1. I hope today's video makes sense. So if you find it useful, please help to share and subscribe. Thank you so much.